Woohoo! What a great way to end this chapter, or actually this unit for this semester, is with volcanoes. What a great way to wrap it all up, put a nice little bow, just in time for the holidays. All right, a volcano is a mountain that forms when layers of lava and volcanic ash erupt and they build up. Now, as we've been talking, magma is rock that exists as hot liquid within the earth, but once it reaches the earth's surface, then it's known as lava. Okay, I love this picture here because it really does show you where all volcanoes do form. All right, so the first one you look at here, this is actually called the mid-ocean ridge, where it's actually in the middle of a divergent boundary where you have two plates that are moving away from one another. They're dividing, and it's allowing this opening for magma to come to the Earth's surface, and then it cools once it hits that cold ocean water floor, or the cold ocean water floor. That's correct. And that's the most common way. And of course, as I talked before, we do have some on land, like in Iceland, and also the Great Rift Valley as well. But it's a little different though. Okay. If you look over here to the right, though, you can see here we have an oceanic, continental, convergent boundary. Okay, so we have this plate going this direction, this plate going this direction. Okay, the more dense one subducts, and as it subducts, it melts back into magma, which melts. There's no more room for that magma to go into the mantle, and it actually overflows and rises into the weak areas of this particular mountain, because it still buckles, it still creates your mountains, just like a continental convergent boundary does. But what's special about this one is it adds a little bit of extra flavor and adds a little bit of that magma, and then it turns into lava once it hits the Earth's surface. Okay, so it follows the path of least resistance, and it creates a volcano. Now, this particular one over here, this is actually an oceanic subduction zone convergent boundary. All right, so you got this plate coming from this direction, and then they are both coming together. They're colliding, compression. All right, and the more dense one subducts underneath the other one. And once again, it melts back into magma, and then it follows a path of least resistance. Now, this particular one, it does take a while for it to form, because it takes over millions and millions of years for all this lava to actually harden and build up on itself. But eventually, once it does go above that water line, voila, we have an island. Okay, so I really do like that. And oh, look at that! Look at that nice force there. Yeah. Convection currents. Love it. Okay, so composite volcanoes, as I was talking about with Dan, remember he has all these anger management issues and how he thinks, oh, this town of St. Gentoof is so stupid. All right. As I said, he can't help the way he was made, his ingredients. It's just the way that quartz, mica, and feldspar, those bonds, they are so tight, so tight. And it's so tight, it doesn't allow pressure to be released. It just builds and builds and builds. Okay, now composite volcanoes are very angry volcanoes. They have a high amount of viscosity, which means it really resists flow. For example, like if you take honey and you're pouring it out of a bottle, look how long it takes for it to flow out, because it does not want to come out of that bottle. Okay, so you would say it's very viscous. It very much wants to resist the flow. That's exactly how composite volcanoes are. And these are very violent eruptions due to the high amount of silica, Dan, quartz, mica, feldspar, which I said is light in color and is very explosive because it holds all that large amount of gas, ash, and lava back to the point to where it actually blows its top. So I have a really cool video here I'm going to share with you. But before that, this is Mount St. Helens in 1980, and you can see all this ash and gas actually spewing from the top and starting to vent somewhat. But generally they will let some release until the final blow. Okay. Now, this video I want to share with you, I really like this one. It's in Indonesia. Once again, look at that. High amounts of Dan, quartz mica feldspar, light in color. Okay. So we're going to go ahead and check it out. So as it's venting here, all right, the next thing you're going to notice here is check out this pyroclastic flow. All right. So pyroclastic flow is ash, gas, and lava mixed in together. Okay, and those ingredients create this wonderful cocktail known as a pyroclastic flow, and it moves very, very fast. And you can see here in this picture, it can actually walk on water. And it's known to actually, it can go across the sea if it has enough energy and can actually cause damage on other islands. Okay, so this is one big bad boy. Okay, so great stuff right there. All right, so going back to Dan, you know, he's got some issues. All right, so gas plus ash plus lava equals the recipe, the cocktail of pyroclastic flow. Okay, so if you can tell here, Mount St. Helens, yes, it's a composite volcano. Now you can see here, check this out. So they kind of had a warning before it blew. They could see all this pressure starting to form, and I always call it Dan's pimple, you know, because he was a teenager and he was about ready to blow. Okay. Anyways, so you can tell it was actually starting to bulge out due to all the pressure, and they noticed some earthquake activity. Okay, so yeah, you will definitely have earthquake activity on around volcanoes or from volcanoes, even if it's not on a fault line. Okay, all right, so that is a picture of some geologists, or actually volcanologists, that were camped out because they had a pretty good idea that it was going to go. All right, now this was after he blew his top. You remember how it was bulging like this? Well, now it's like this, okay? It's gone, okay? After he erupted, the whole top came off because there was so much pressure. Not a very nice guy, okay? All right, this next one here is a shield volcano. This has a low viscosity, which means it has a fast flow like cola, okay? So whenever you go in there and get yourself some cola and you pour it out into a cup, you notice it pours pretty fast. It doesn't resist the flow. It just goes with the flow, man. So it's not very viscous is what we call it, okay, because it moves fast. And volcanoes that are comprised of quiet lava flows. The lava has a low amount of Dan, okay, so the bonds aren't real tight. It's actually has a very nice, pleasant personality, really laid back. And because the bonds aren't as tight, because it has a low amount of the silicates, quartz mica feldspar, it just flows. Whenever it needs to go, it just flows. It just goes with the flow. Okay, and they're always dark in color. All right, and these volcanoes are very nice and gentle sloping sides with a very wide base. Okay, so if you notice, the composite's higher, way higher, and it's steeper, but the shield is just like, we just go with it, man. We just roll with it, okay? All right, so I have a pretty cool video here showing you, this is absolutely gorgeous, okay? And this is actually in Iceland, okay? So we're gonna watch this, see how pretty it is. You can get close. You can see how beautiful the flows are, the nice little fountains, and you don't see the gas, you don't see the ash. All you just see is the lava and the beautiful expression of a fountain that goes along with it. Okay, we do have some steam because of all the heat that's causing the water to condense around it. But yeah, it is just drop dead gorgeous. It's definitely a sight to see there. Okay, see the fountains. So this is a very nice one. Okay, now that's what we call a shield volcano. Alright, so your assignment that is due tomorrow. Alright, so you have to explain which video is nice and which one is mean. You may make it into a story if you like. You don't have to. Just make sure you use the words quartz, mica, feldspar, Dan. Make sure you talk about how their lava is different or the same. Talk about how what is pyroclastic flow, and talk about how they are when you talk about viscosity. Okay. Make sure you do not give me lightly salted chips. I want the chips. I want the meat, the cheese, the lettuce, the tomato, the guacamole, the salsa, the sour cream. I want it all. Have this for me tomorrow. Peace out.